Hello, my dear students. Welcome to Chemflix again. So, in this session, we are going to discuss about the Theme 2 NCRT carbon and its compounds, especially for 2022, the new syllabus. I'll introduce the Class 10 Theme 2 Subject Science Board Exam 2022 21-22 chapter wise weightage as per the CBSE sample paper 2022. So, here for this theme 2, 4 chapter 4 is there, chapter 5 is there, chapter 8 is there, then 9 is there, 12, 13, 15. These are the chapters of for theme 2, and among them 4 and 5 belongs to our chemistry, carbon and its compounds, and periodic classification of elements. And as per the CBSE sample paper 2022 plus that pre-board exam, you can see the weightage from carbon and its compound is 5 mark, and from periodic classification of elements 5 mark. Same weightage from both this. There are expectation. Yeah, it may vary. Yeah, it may vary. Total 40 marks, as you know. So here we are going to discuss this carbon and its compounds at a glance. What all are the questions you can expect from this chapter? How you want to treat this chapter to get to score complete marks from this chapter? Okay, so we are going to see. So here for the syllabus of 21-22 from this chapter is only 2-3 sessions, that is covalent bonding in carbon compounds, versatile nature of versatile nature of carbon, and homologous series. And the deleted part is nomenclature of carbon compounds containing functional groups. That means functional groups, that is halogen, alcohol, ketone, aldehyde, alkane, alkane. All the nomenclature they have deleted. Differences between saturated and unsaturated hydrocarbon deleted. Chemical properties of carbon compounds, especially combustion, oxidation, addition and substitution reaction deleted. Ethanol, ethanoic acid deleted. Soaps and detergent deleted. That means you are golden children. You know, almost 60%. No, almost 70% of this chapter is deleted. Remaining is covalent bonding in carbon compounds and versatile nature of carbon, homologous series. Only these three topics you have to study from this entire chapter, that is carbon and its compounds. Okay, so let's discuss without wasting much time. So, my plan for today's session is we have to discuss some questions and then we have to solve the questions. Okay, so the first question is, why does carbon atom form a large number of compounds? Okay, why does carbon atom forms a large number of compounds? And the subpart is, how does carbon attain stable electronic configuration? How does carbon attain stable electronic configuration? Okay, that is the first question. And the second question is, define catenation. Define the term catenation. Explain why is carbon tetravalent in nature. Explain why is carbon tetravalent in nature. Okay. So why does carbon atom forms a large number of compounds? You know, organic chemistry, the branch of chemistry, that is organic chemistry, it is because of the versatile nature of the carbon, right? So you have to study this versatile nature of carbon, and what is the reason for carbon atom form a large number of compounds. Okay, listen. Okay, the question it is clear now. And the subpart of the question number 1 is, how does carbon attain stable electronic configuration? Okay, catenation. Why is carbon tetravalent in nature? Okay, 2 mark question. This is also 2 mark question. This is also 2 mark question. So let's discuss the answer. So here, you know carbon atom. Okay, do I need to change the color of my pen? Okay, I'll change it to yellow color. Okay, carbon. Okay, carbon. Carbon, you know the atomic number of carbon is? What is the atomic number of carbon? 6. Okay, so the electronic configuration you can write as 2, 4. Okay, electronic configuration will be 2, 4. So how many electron it needs to attain the nearest noble gas configuration? Either it needs to lose this 4 electron, then it will attain the configuration of helium. Okay, and if it gains 4 electron, if it is losing, it will attain the configuration nearest noble gas configuration of helium, and if it is gaining, Then it will attain 2,8, that is neon. Neon, the atomic number is 10. Helium, the atomic number is 2. Okay. Is there any doubt? Okay. No, nothing. So helium, the atomic number is 2. Neon, the atomic number is 10. So here, carbon neither loses 4 electron or it gains 4 electron completely because of two reasons. Okay. If carbon atom gains 4 electrons, you know, in the nucleus, how many protons are there? The atomic number of carbon is 6. Therefore, 6 protons are there. And this 6 protons cannot hold the 10 electrons. Okay. If it gains, say, 4 more electron, this is our carbon atom 2, 4. Okay. This is our carbon atom 2, 4. 1, 2, 3, 4. Okay. 2, 4. So if it gains, what is the situation? This 6 proton cannot hold the 4 electron. This 6 proton cannot hold the 6 proton cannot hold the 10 electrons. Now how many electrons here? 10 electrons. The 6 proton cannot hold the 10 electrons. So it is not possible. And if it gains 4 electrons, suppose if it gains 4 electron, what happens here is it cannot gain 4 electrons. Why? Because it cannot lose the 4 electrons because ionization energy problem, and it cannot gain 4 electron. It is because this 6 protons cannot hold the 10 electrons. Clear? It cannot lose the 4 electron because of ionization energy problem, and it cannot gain 4 electrons because of the 6 proton cannot hold the 10 electrons. Okay, so it shares its 4 electrons. So rather it is losing or gaining is not possible. Losing or gaining is not possible. So what it will do? It will share its 4 electron. It will share its 4 valence electron with other atoms of carbon or with atoms of other elements to attain the noble gas configuration. So that means sharing of electron, okay, sharing of electron or the bond formed by sharing of electron is called covalent bond. So here covalent bond, carbon always forms covalent bond. Bond which are formed by sharing of an electron pair between two atoms are called covalent bonds. So you know, right? Now the important point from this area is the versatile nature of carbon. So this is versatile nature of carbon. It is in our syllabus. So yeah, right. It is in our syllabus. So versatile nature of carbon, it is because of the two reasons, that is the catenation, property of catenation, and also the tetravalency of carbon. Catenation, tetravalency. Okay, listen here. This tetravalency means carbon share its 4 electron, right? 4 electrons is sharing. 4 electron sharing. That means the carbon, it is sharing 4 electrons, and it is the valency of the carbon is 4. The valency of carbon is 4. That is what is called a tetravalency of carbon. Carbon has 4 valence electron. Carbon can bond with the 4 other carbon atom, monovalent atom, oxygen, nitrogen, sulfur. For example, I will show you. Carbon bonded with the chlorine, carbon bonded with the oxygen, carbon bonded with the nitrogen. So what it will do? It will share its electron, right? It will share its electron to attain the nearest noble gas configuration. That is what is called the term tetravalency. The valency of carbon is 4. What is the valency of carbon? Valency of carbon is 4. Now the second term, that is catenation. Carbon can link with the carbon atoms. By means of covalent bonds to form long chains, branched chains, closed ring compounds. So what all are the things they will form? Okay, covalent bonds to form long chains, branched chains, and closed ring compounds. Okay, long chains, branched chains, closed ring compounds. Carbon atom may be linked by single bond, double bond, or triple bond. So I will tell you some of the examples. So here long chains, for example, pentane. Okay, pentane. C single bond, C single bond, C single bond, C single bond, C. Long chain. How many carbon atom? 1, 2, 3, 4, 5. That is pent. single bond any, then valency they have to satisfy with the hydrogen atom. Okay, then again the next one, double bond C, double bond C, triple bond C, triple bond C. Okay, then branched chain like this you can see. Okay, this like this you can see, or closed ring compound like this you can see. Okay, closed ring compounds. So that is the property of catenation. Catenation means carbon can link with the carbon atom by means of covalent bonds to form long chain, branched chain and closed ring compounds. Carbon atoms may be linked by single bond, double bond, triple bond or triple bond, etc. Okay, so here catenation means the self-linking capacity of carbon atom with other atom. Self-linking capacity of carbon atom with itself and with the other atom, that is called catenation. So these two properties are very important, and because of this property, that is the versatile nature of carbon, and this is the reason why carbon forms so many compounds. This is the reason why carbon forms so many compounds. So is it clear? Okay, now we are going to the next slide. That is the next question, next set of questions that we are going to solve now. What are covalent compounds? So we already discussed about the covalent bonds. So now what are covalent compounds? Covalent bonds means what? The bond formed by sharing of electron. Bond formed by sharing of electron is called covalent bond. Sharing of electrons is called a covalent bond, and covalent compound means the compounds which are formed by the sharing of electron is called covalent compounds. Okay, now the next question is, give reason why covalent compounds are generally poor conductors of electricity. This is another one important question. Covalent compounds are generally poor conductors of electricity. Why? Again, I'll repeat the question. Covalent compounds are generally poor conductors of electricity. Why? Why? What is the reason for the poor conductivity of the covalent compounds? So, covalent nature of carbon compounds, very important. Carbon is tetravalent. We already discussed now. Carbon is tetravalent. The by the carbon, the electronic configuration, atomic number is 6. That is 2, 4. So it needs 4 more electron. So carbon chooses sharing of electron. The valency of carbon is 4. Valency means the combining capacity. Valency of carbon is 4. So it is tetravalent. That means it is tetravalent. Okay, tetravalent. So it does not form ionic compound. Ionic compound means, what do you mean by ionic compound? Ionic compound or dianic bond means transfer of electron. Ionic bond means transfer of electron. The bond formed by transfer of electron is called ionic bond. The bond formed by transfer. We are dealing with the sharing of electron. That means covalent bond. Okay, covalent bond. So here, it does not form ionic bond by either losing 4 electrons or by gaining 4 electrons. So carbon atom form only by sharing of electrons, and hence forms only covalent compounds. And the property of these covalent compounds are have low melting and boiling point. They have low melting and boiling point. Why they have low melting and boiling point? Another one question. It is because of the weak intermolecular force. They have low melting and boiling point, and they are generally poor conductors of electricity. You can expect this question also. Oh, why covalent bonds or while covalent compounds are low melting and boiling point? It is because of the weak intermolecular forces. Why covalent compounds are generally poor conductor of electricity? Because there is sharing of electrons and no ions are formed. Because there is a sharing of electron. In the case of ionic compound, Makale, listen here. In the case of ionic compound, we will get one positive ion. That is called a cation, and a negative ion called anion. Okay, negative ion called anion. But in the case of covalent compound, there is no covalent bond. Covalent bond is formed by sharing. There is no formation of cation and anion. So there is no ions are formed. Therefore, they are generally poor conductors of electricity. Is it clear, everyone? So we are moving to the next set of questions. First question is, write the molecular formula and the electron dot structure of the following. Okay, carbon dioxide, ammonia. Already you are studying all these things in ninth standard, so no need to worry. Write the molecular formula and electron dot structure of the following, that is water, ethane. Okay, water also you are studying in ninth standard. Ethane you are studying in the 10th standard. You know ethane contains how many carbon atom? 2 carbon atom. Eth means 2 carbon atom, and YNE means triple bond. What is the bond here? Triple bond. Okay, eth means 2 carbon atom, and wine means 3 bond, that is triple bond. And then it is 3 valence is already satisfied. The remaining 1 valence it is satisfied with the hydrogen. So this is the structure of ethine. Ethine. And water you know H2O. Okay, ammonia you know NH3. Okay, carbon dioxide you know CO2. So what you have to do, write the molecular formula. Molecular formula of written electron dot structure. How you can to draw electron dot structure? Write the molecular formula here. Write the electron dot structure of the following. Okay, 2 marks here, 2 marks here. Similarly, you can expect so many questions related to the electron dot structure. So this electron dot structure is another one important portion from this chapter. You can expect, okay, you must expect the electron dot structure. You have to study how to draw the electron dot structure of a particular compound. Okay, so we'll discuss. For example, hydrogen. Okay, hydrogen. Hydrogen, you know the structural formula of hydrogen is this one. So a bond is formed by sharing of two electron. Sharing of two electron. Okay, sharing of two electron. Sharing of two electrons. So here hydrogen atom, you know the atomic number of hydrogen is 1. Similarly, one more hydrogen atom. We are talking about H2, hydrogen gas. So H2. So what they are doing, they will share its electron like this. So this now the hydrogen atom possesses 2 electron, attains the nearest noble gas configuration, that is helium. Okay, so here this hydrogen also got 2 electrons. So this is the electron dot structure of hydrogen. Is it clear? Is it clear again? I'll repeat it again once more. Hydrogen, you know the atomic number of hydrogen is 1. So hydrogen, this is a 1 electron. With this electron possessed to this hydrogen. And again one more hydrogen atom is there. It is because of H2. So here hydrogen also possesses 1 more electron. So what they will do? They will share this electron. How are they sharing? Okay, this hydrogen, it gets this electron of this hydrogen, and now this hydrogen attains the nearest noble gas configuration, that is helium, and similarly this hydrogen shared its electron. So both are getting 2 electrons each from this bond. Both get 2 electron. Okay, both get 2 electron. So this is hydrogen. Similarly, oxygen. Oxygen, you know the electronic configuration. Oxygen, atomic number of oxygen. What is the atomic number of oxygen? 6. No, 8. Okay, 8. So the electronic configuration will be 2, 6. That is the outermost shell containing how many electron? 1, 2, 3, 4, 5, 6. Outermost shell contain, that means valence electron. What is the valence electron here? 6. So similarly, O2, oxygen gas means O2, no? This oxygen also possesses 6 electron. Now what will you do? This oxygen needs how many electron? This oxygen needs how many electron? 8 electron. How will they share? Like this they will share. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And what will this oxygen do? This oxygen will share its electron. Now 1, 2, 3, 4, 5, 6, 7, 8. So both of them attains the nearest noble gas configuration, that is neon. Neon atomic number is 10. Here again we are taking the next example, that is nitrogen. Nitrogen, you know what is the atomic number of nitrogen? Nitrogen, the atomic number is 7. So the electronic configuration will be 2, 5. So nitrogen, I am going to draw nitrogen. The outermost shell containing how many electron? 5 electron, that is a valence electron. 1, 2, 3, 4, 5. Similarly, this nitrogen also 1, 2, 3, 4, 5. So what will this nitrogen do? This nitrogen will share its electron. So here 3 plus 3, 6, 6 plus 2, 8. And here also 3 plus 3, 3 plus 3, 6 plus 2, 8. So both of them attain the nearest noble gas configuration, that is neon. Yeah, okay, you got it right. Similarly, so nitrogen we completed, oxygen we completed, or hydrogen we completed. So what about this ethane? Okay, ethane. Ethane, you know ethane. The ethane, it is ANE, no? ANE. ANE is alkane. CnH2n plus 2. That is the general formula. So ether means how many carbon atom? 2. So 2 into 2, 4. 4 plus 2, 6. H should be 6. C2H6 is the molecular formula. So here you are writing the structural formula of ethane, and each of this bond means 2 electron. Okay, each of this bond means 2 electron. So this 2 electron, okay, again this 2 electron, this 2 electron, this 2 electron, this 2 electron, this 2 electron. So what will they do? This is how hydrogen will share its electron. Again this will share the electron, 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 this will share the electron. And what about this carbon? The carbon it share like this one. Okay, similarly this carbon will share like this one. You got, right? Okay, let me give some time. I'll rub this and I'll show you again. Okay, give me some time. Okay, give me a minute. I'll show you. I'll show you. Okay, Pakale, listen here. So you know carbon. Okay, carbon, the valencies. What is the valency of carbon? 4. 1, 2, 3, 4. Okay, you know the valency of hydrogen. What is the valency of hydrogen? Valency of hydrogen is 1. Similarly, one more carbon atom is here. How many carbon atom? 1, 2, 3, 4. Here one more hydrogen atom. 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 This is according to the structure. Now what happens here is, okay, already this carbon possesses 4 electron. It needs this electron, this electron, this electron, this electron. So what will they do? Okay, it's not changed. Color not changed. Wait a minute. Wait. So here, look at here. This is how this carbon atom will share its 8 electron. Okay, share its electron. Okay, you get 1, 2, 3, 4. 4 plus 4, 8. Similarly, this hydrogen atom to this hydrogen atom to this hydrogen atom to. And what about this carbon atom? Similarly, that carbon atom also share its electron like this. Okay, and this, what about this hydrogen atom? This one, this hydrogen atom, this one, this hydrogen atom, this one. Okay, so this is the electron dot structure of ethane. Similarly, ethine. Sorry, it is not ethine, it is ethene. E T H E N E. Ethene. C2H4. CnH2n. That is the molecular formula, general formula CnH2n. Here how many carbon atom? 2. 2 into 2, 4. C2H4. Here you can see. So here how many bonds you can see? Double bonds. Double bond means sharing of 4 electrons. So 1, 2, 3, 4. 4 electrons they have shared between these two carbon atoms. This is how they can draw. Okay, try madungo. You please do it yourself. You will get. Okay, try it 2-3 times. You will definitely get how to draw the electron dot structure. Moving to the next slide. That is the next set of question. You can see here, which of the following is a good conductor of electricity, diamond or graphite? You know, diamond and graphite are the different allotropes of, different allotropes, no? Allotropes of carbon. Okay, allotropes of carbon, diamond, graphite, fullerene. So, which of these following is a good conductor of electricity? Which one is a good conductor of electricity and why? That is the question. So, we'll see. Allotropes of carbon, they especially you have to study about these two, that is graphite and diamond. Both are very important. Okay, hexagonal graphite is, what is graphite? You can see in your textbook what is the structure of graphite and what is the structure of diamond. Graphite is a hexagonal arrays placed in layers one above the other. So graphite, it is placed one above the other like this, like this, one above the other. It is a two-dimensional structure. It is a two-dimensional structure. Each carbon atom is bonded to 3 other carbon atom. One of the bond being double bond. One of the bond is double bond. Okay, so one of the bond is double bond C, double bond C, and it is bonded to 3 other carbon atom like this. 1, 2, 3, 4. Valency it is satisfied, right? Valency is satisfied. It is smooth and slippery. Okay, you know the lead of a pencil, right? Lead of a pencil. Lead of a pencil is made up of graphite. It is a good conductor. That also you know. It is used as lubricant. in pencil lead, etc. That is graphite. Graphite is a hexagonal array. Hexagon, what is hexagon? This is hexagon. 6 side, 1 2 3 4 5 6. Again on the top of this another one layer, on the top of this another one layer. So this is a two-dimensional structure. Two-dimensional structure, what? Graphite. And because of this particular a particularity in their structure, they can conduct electricity, they are smooth and slippery, and they are used as lubricants. Okay, coming to diamond. Diamond is little bit different from graphite, as both are allotropes of carbon. Diamond is a three-dimensional structure. You know, diamond is the very hardest substance in the nature. You know, it is the hardest known substance in the nature. Each carbon atom is bonded to four other carbon atoms. So there is no double bond, there is only single bond. You can see here, only single bonds are there. Okay, only single bonds. Okay, okay, only single bond. Here you can see a double bond, and it is a bond conductor. Okay, there is no free electron, or there is no conductivity. It's not possible in diamond. Uses cutting tools, jewelry. These are the jewelry, you know, jewelry, and it is very hard, so it is used for cutting tools. So this is the main important of allotropes of carbon, and that is the reason why what lead pencil or a graphite is the good conductor of electricity. Graphite is a good conductor of electricity because of this double bonded characteristics. Each carbon atom is bonded to three other carbon atom. One of the bond is big double bond, and also it is a hexagonal array placed layers one above the. Now moving to the next bunch of question. What is a homologous series? Give an example. Write down any three characteristics of the compounds of homologous series. So we have to discuss what is homologous series. Homologous series is very simple and very important. A series of compounds which have same functional group substitutes for hydrogen in a carbon chain is called a homologous series. Example: alkanes, alkenes, alkynes. Okay, for you only this needed. Alkynes. Okay, characteristics of homologous series: having same general formula, differ by CH2 group. Very important. Same general formula, you know the general formula of alkane. Alkane's general formula. What is the general formula of alkane? CnH2n plus 2. Alkene, CnH2n. Alkyne, CnH2n minus 2. So these are the general formula, and you know they are differ by CH2 group. That means CH2 group is what is the mass of one carbon atom? Carbon atom, the mass is 12, plus mass of one hydrogen atom is 1. How many hydrogen atom? 2. So 12 plus 2 is equal to 14 unified mass. So the molecular formula difference between two members of this homologous series is 14 unified mass, and show regular gradation in physical properties but have same chemical properties. They have same chemical properties. Why? Because their molecular formula is same. So they have same chemical properties but different physical properties. Very important. You have to study hard. You have to study hard, Makale. Homologous series, very important. Okay, so a series of compounds in which same functional group substitute for hydrogen is called homologous series. They have same general formula, differ by CH2 group, and the molecular formula difference by 14 unified mass. They have same chemical property and different physical property. Now, the next bunch of question, that is structural isomerism, and draw two structural isomers of butane. So butane means how many carbon atom? But means 4 carbon atom. 4 carbon atom. And An means single bond. Ane means alkane. Alkane. Single bond. Okay, single bond. Okay, now listen here. What is the structure of butane? How many carbon atom? 4 carbon atom. 1, 2, 3, 4. Only single bond. So between two carbon atoms, single bond. Now you have to satisfy the valency of carbon atom with the hydrogen atom. So what is the structure of butane? This is the structure of butane. And what is the molecular formula? Since it is an alkane, the general formula of alkane is CnH2n plus 2, and therefore how many carbon atom? 4 carbon atom. So N is equal to 4, C4, H 4 into 2 plus 2, C4, H 10. C4H10. Now count Manugo. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this is C4H10. So you have to define structural isomerism at first. What do you mean by isomerism? What do you mean by structural isomerism? Then you have to draw two isomers of butane. Okay, let's see. Structural isomerism is compounds with the identical molecular formula. So same molecular formula. Okay, what is this? Okay, what is this? Same molecular formula. Same molecular formula but different structures are called structural isomers. So different structures. The two isomers of structural isomers of butane are, here you can see it is normal butane. Okay, normal butane. And here 1, 2, 3, 4. So here in the second carbon atom there is a branching. So 2-methyl propane. 2-methyl propane. Those who want to study how to name a particular organic compound, already I posted the how to name a particular compound in my channel. Though I will put a key here. Okay, iCard here I will maintain an iCard here. Please go and watch how to name an organic compound. So here this is 2-methyl propane. Okay, how to find out the straight chain first. Straight chain contains 3 carbon atoms, so propane. And then the second carbon atom there is a substituent, that is 2-methyl substituent, and it is the second carbon atom, so 2-methyl propane. Similarly, the structural isomers of pentane. The 3 structural isomers of pentane with the molecular formula is C5H12. You can see this is normal pentane, this is neopentane, and this is isopentane. Isopentane, the other name of isopentane is 2 second carbon atom में 1 methyl substituent, so 2-methyl butane, and this is 2,2-dimethyl propane. 2,2 hash now hyphen dimethyl propane. 2,2-dimethyl propane, that is neopentane. Okay, this is neopentane. This is one CH3, this is one CH3, this is one CH3, this is one CH3, and this one is C. Okay, this is neopentane, and this one is isopentane. Isopentane, what is the name of isopentane? 2-methyl butane. 2-methyl butane. This is 2,2-dimethyl propane. So those who want to know much about the nomenclature of an organic compound, you please go and watch this video. Okay, so this is the structural isomers. And the last question I just want to discuss with you is a case based or source based question. I'll go to read. Okay, all of you please read yourself. Carbon has a unique ability to form bonds with other atoms of carbon, giving rise to a large number of compounds. Since carbon has a valency of 4, it is capable of bonding with 4 other atoms of carbon or atoms of some other elements. The bond that carbon forms with most of the elements are very strong. The reason for the formation of strong bonds by carbon is its small size. Okay, so what is the reason for the carbon atom to form strong bonds? The reason for the formation of strong bonds by carbon is its very small size. So you know the size of the carbon. Carbon, the atomic number is 6, right? It is very small. Now the question is, draw the structure of carbon compounds having 5 carbon atom and 12 hydrogen atom. So how will you write this? Carbon atom having 5 carbon atoms means C5. Okay, C5, and 12 carbon atom means H12. C5H12. C5H12 is an alkane, alkene, or alkyne. That you have to find out. You know the molecular general formula of an alkane is CnH2n plus 2. We'll check whether 5 into 2, 10, 10 plus 2, 12. Yeah, it satisfies the alkane, general formula of alkane. Since here is 5 carbon atom, it is pentane. So what do you have to do with this? Draw the structure of pentane. Now, if only oxygen is to be bonded to carbon, how many of them will be bonded to one atom of carbon? If only oxygen is to be bonded to carbon, how many of them will be bonded to one atom of carbon? So, if only oxygen is bonded, C double bond O. Again, one more. What is the valency of carbon? Valency of carbon is 4. Now, what is the valency of carbon? Valency of carbon is 4. 4. So, how many oxygen can be bonded to a carbon atom? 2 oxygen atom. 2 oxygen atom can be bonded to a carbon atom. Okay. Why? Because the valency of carbon is tetravalent. carbon is tetravalent. And what is the valency of oxygen? Oxygen, the atomic number of 8, 2, 6 is the electronic configuration. So how many electron it needs? 2 more electron it needs to complete the octet configuration. 6 plus 2, that means 2, 8. So this 2 electron, from where did it get? It get from the carbon atom, since carbon is tetravalent. So how many oxygen atom can be attached to the carbon atom? 2 oxygen atom can be attached to the carbon atom. Okay. Now the C question, name the property which enables carbon to form bonds with the other atoms of carbon. Now we already studied. Now it is catenation. The property is catenation. Catenation. How does small size of carbon helps in forming stable bonds? The small size of bond, since carbon is very small, so it can accommodate 4 hydrogen atom. It can accommodate 4 hydrogen atom, and also it can accommodate oxygen atom. It can hold oxygen atom, nitrogen atom, carbon atom. Okay, that's why it can form stable bonds with other atoms. Or what do you mean by tetravalency? Tetravalency of carbon we already discussed. Carbon atom, the atomic number is 6, so the electron configuration is 2, 4, and the valency of carbon is 4. Write down the number of covalent bonds in propane, butane. Okay, another one interesting question. So you have to know how to draw the propane, right? So I'll change the color to the yellow. So here C3, 1, 2, 3. H8. H8 means CnH2n plus 2. You know, 3 into 2, 6 plus 2. N is equal to 3. So C3 H2 into 3 plus 2, that is 3 into 2, 6, 6 plus 2, 8. So C3H8 is an alkane. So here hydrogen, here one hydrogen, here one hydrogen, here also hydrogen. Okay, valency is satisfied with the hydrogen atom. So what here are to do? You know the valence. Carbon always forms covalent compound, right? Sorry, carbon always forms covalent bond. So here how many covalent bonds you can see? This is one covalent bond, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number of covalent bonds of C3H8 is 10. Similarly, C4H10 is, again you have to draw 1, 2, 3, 4. So here 3 covalent bonds, 3 plus 1, 4. Here CH2, here CH2, here CH3. So here 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13. You have to do it yourself. And if you have any, if I am mistaken, please let me know in the comment box. Okay guys. So thank you all guys. Thank you. And if you like this video, please give a like, and also please subscribe to channel if you are new to this channel. Okay, also please share among your friends. Thank you all. Thank you so much. See you in the next video.